All right, beautiful. So now that we're talking about exponents, we are going to talk about squares and square roots and cubes and cube roots, which really just undo one another. So today we want to be able to estimate and evaluate, and this is kind of an interesting thing, to estimate square roots. So we're going to talk about that and evaluate square and cube roots. So perfect squares. The square of an integer is called a perfect square. The square of an integer is called a perfect square. So we want to go ahead and complete this list of perfect squares below. What is 1 squared? 1. What is 2 squared? 4. 3 squared? 9. 4 squared? 16. 5 squared? 6 squared? 36, because 6 times 6, right? So 7 squared is 49. 7 times 7 is 49. 8 squared? 64. 9 squared? 81. And 10 squared? 100. So all of these numbers right here are called perfect square numbers. Now, why are they called perfect square numbers? Does anyone know why we call them perfect squares? Like, why do we use the word square? Don't know, right? It comes back to multiplying. It goes back to multiplying. Remember when I told you, or we did the partial products, I made you draw the boxes, and we figured out you did all the multiplying. It was kind of annoying. There's a reason for that. Because if I were to multiply, let's say my favorite is 5 times 5. What we would have is 5 rows, 1, 2, 3, 4, 5 rows of 5 blocks in each row. And if we did that, well then, how many little blocks are there? How many? 25. If I were to actually count up 1, 2, 3, 4, 5, 10, 15, 20, 25, there would be 25 little blocks. In what shape do they form? A perfect square. It's a perfect square because it's 5 on one side and 5 on the other. And what shape is that? It's a square, okay? You can do that for all of these numbers. 49 forms a perfect square of 7 by 7 on the sides, okay? So they are literally called perfect squares because you can arrange 49 little unit cubes in a perfect square, okay? And so that's why they're called perfect squares. Now, the opposite, I don't really like, I'm going to use the word inverse. The inverse is a better word of squaring a number is finding the square root. They're inverse operations. They undo one another. And so, for instance, I might say, hey, the square root is this symbol. That's the square root symbol. And I might say, like, hey, what's the square root of 81? Well, here's the square, the perfect square number 81. And when we ask for the root, we want the base, whatever that base happens to be. So the square root of 81 is just, where did it come from? It came from 9 being squared. And so when we say what's the square root of something, we're looking for, hey, what base number created that? Okay. So positive numbers have, it turns out, 2 square roots. And that's because what numbers can you square, for instance, to get 16? What number squared gives you 16? 4. Now, there happens to be another number that we can square that also gives us 16. 8 squared is 64. Yeah, a little weird. what about negative 4? What if we square negative 4? What does that mean? Negative 4 quantity squared. Is it negative, or is it negative 4 times negative 4, which equals positive 16? Okay? So it turns out that 4, but also if I take the whole of negative 4 and I square the whole entire thing, I can also get a positive 16. So there's actually two base numbers, two bases that give us that 16. Negative numbers have 0 square roots. I cannot take the square root of negative 25. It is not a real number. So we cannot take the square root. You'll notice here that that negative is underneath. And what number has only one square root? No, again, so negative 1 also would give you that number 1 when you square it. So one number wasn't included on here. 0. Yeah, 0 actually is the only number that the square root is just 0, which is kind of interesting. All right, so here's the notation, a radical sign. This is the radical right here. We can say radical x. We could say square root of x is used to indicate the square root of x. Radical x or square root of x is used to indicate the positive square root of x because there's a positive in front of it. And negative square root of x is used to indicate the negative square root of x because there's a negative sign in front of it. So we don't actually have to think about positives and negatives too often. We just want to do what it says. So I want to find each square root. What is the square root of 49? 7. All we want is, going back to our list here, we're simply looking for that base number, which, where did 49 come from? It came from 7, okay? What's the square root of 9? 3. Again, here's our perfect square number. Where did it come from? It came from the base of 3. This one has a negative in front. So we're going to keep the negative along for the ride. And we want to know what's the root of 4.
Computer Lab presenting, Sarah Hector, Wanda Lee, John Donnelly, and Adrian and Damien Kaufman. Thank you.
All right. So what's the root of 4? 2. Yep. So there's the 4. And when we say what's the root, we want to know what was that base that it came from. It came from a base of 2. Ooh, here's one. I don't have this one on my list. There is a negative, so I'm going to bring that negative along for the ride. Does anyone know what the root of 289 is? It is 17. I didn't know that. So what can I use if I didn't know that? My calculator. Okay, on your calculators, ladies and gentlemen, you do have a square root button. You can see it right here. Right here. Can you see my finger right there? And what color is that square root symbol? Blue. What does that mean if it's blue? You got to use the second button. So we do second square root of 289. And we get 17 with a negative out in front. Does anyone know this? Again, here, number 5, we have a negative out in front. What's the square root of 196? Yeah, here it's 14 with a negative. Ooh, and I don't know the square root of 484. Let me see. The square root of 484, 22. 22 squared is 484. Interesting. All right. Here's an interesting one. When we have a quotient underneath a radical, it turns out that we can split it up into 2 little baby square roots. So split that up into baby square roots. What's the square root of 1? 1. What's the square root of 16? 4. Good. Again, there's your square number. And when we want the root, it's just whatever the base happens to be. It's 4. All right, here we have a negative out in front, and I'm going to split this up into radical 81 over radical 25. There's a negative in front. What's the square root of 81? 9, because 9 times 9 gave me 81. What's the square root of 25? 5, because 5 times 5 is 25. We only want the base. We want that number 5. And what's number 9 going to be? 7 12. Very good. The square root of 49 is 7. The square root of 144 is 12. Beautiful. Good job. All right. Perfect versus non-perfect squares. Circle each value that is a perfect square. Will you take a second and go ahead and circle all the perfect square numbers?
Is it just like the same number?
Yeah, so this is, for 49 is a perfect square. So yeah, all these in yellow are perfect squares. And of course, this list goes on forever. It goes on a long ways, right? We don't have the whole list. Let's see. I'm going to give you 15 more seconds. Okay. Give me a perfect square. Which one of these is a perfect square? 9. 9 was on my list. What was another one? 121 was on my list. What else? 1. What else? 64. There's one more. 324. Yeah. So 324, I could do the square root of 324, and it turns out to be 18 squared gives you 324. Those are nice to know. It turns out all of those numbers would be on our list that we started to generate. So they are lovely little perfect square numbers. That's a big list of perfect squares, right? Oh, you can't see what I did. There you go. So that's a long list of perfect squares. If a number is not a perfect square, it's called a non-perfect square. All right? It doesn't make a perfect square, okay? So non-perfect. All right, let's turn the page. All right, estimating. I always, growing up, wondered how you actually, how does the calculator figure out that that's the decimal? That would give me 10 if I multiplied it by itself. So if I take that decimal and multiply it by itself, I get a number very, very close to 10. Isn't that crazy? Yes. Okay. So I always wonder how it does that. Well, it turns out, and I never learned, they didn't teach me how to calculate a square root, okay? We never learned it. The generation before me did. And so I found it in the textbook. Guess what it is? It's long division. It's just long division. So they tweak the long division process just a little bit, and actually can calculate this using something similar to long division, okay? But that's kind of interesting that we get a number very close to 10 when we take that decimal and multiply it by itself. We get that 10 nearly back. Certainly that's close enough, yeah? 9.999999999999999. That's really just 10, okay? That's called round-off error, okay? So we want to be able to identify two consecutive integers. What does consecutive mean? That's a big word. What does consecutive mean? Continuous. Consecutive means in order. Consecutive means in order. So 3 consecutive integers would be 3 numbers in order. So 3, 4, and 5. Those are the numbers in order, okay? So consecutive means in a row, one right after the other, okay? So give me 3 more consecutive integers. 9, 10, and 11. Perfect, okay? So we want 2 consecutive integers, so that would be like 4 and 5, or 16 and 17, okay? So we want a couple of consecutive integers that the square root falls between. And I think this is kind of interesting. What I'm going to do here, I'm going to write we're just going to do a couple here, just to show you, and then you'll figure it out pretty quickly. I'm going to put radical 10 in the middle. That's what I'm interested in. And it turns out that radical 10 is going to be less than radical 11. I don't know radical 11. It's going to be less than radical 12. It's going to be less than radical 13. It's going to be less than radical 14. Oh, this is taking a while here. It's going to be less than radical 15. And it's less than radical 16. Oh, radical 16 is very special. What is the square root of 16?
4.
Oh, that one's 4. Oh, that's interesting. Hey, that's kind of a nice one to know there. That is 4. And it turns out that radical 10 is greater than radical 9. Ooh, that's an interesting one. What is the square root of 9?
3.
3. Now, I wrote that out really long, and that seems a little bit exhaustive, right? But here is radical 10, and this is the one I'm interested in. And you can see that radical 10, is it very close to radical 9? Okay. But it is bigger, right? Because 10 is bigger than 9. So radical 10 is bigger than radical 9. And it's very far away from radical 16. So there are 2 integers here. Radical 10 is going to be between 4 and 3. So radical 10 is greater than 3, but it's also going to be less than 4. And if we had to approximate the square root of 10 to the nearest tenth, if you think about how close it is to radical 9, would you say it's like 3.5? Do you think it's like right in the middle between 3 and 4? Or would you think that would fall somewhere over here would be right in the middle? Yeah, right? So somewhere over here would be right in between 3 and 4. So maybe it's because it's so close to radical 9. Maybe it's like a 3.1 or a 3.2. All right, yes, of course we have calculators, but there it is. There's the square root of 10, 3.1.
How do you get square root on the calculator?
So it's right here in blue. Okay, so you do blue and then the square root. So you do the second key and then the square root. All right. So if I were to estimate that, it would be like 3.1, 3.2. And that's cool to be able to do that. So 115, let's think back to our list here of perfect squares. We want 115 somewhere between our little list. Ooh, 115 is bigger than 100. What's the next perfect square number? Hi. 11 squared is? 121. 121, thank you. All right. So, right between 115 is going to be less than the square root of 121 and greater than the square root of 100. What's the square root of 100? 10. And what's the square root of 121? 11. So 115 is somewhere between 10 and 11. Yes, ma'am.
Any 8th graders that dressed up for Spirit Week?
Stand up. Let's see you. Let me see. I want to see you. Yeah, dressed up. Hey, what decade are you? Yeah.
Technically, I'm 2025.
2000s? Oh, okay. Oh, I guess technically we all could have dressed up as 2025, huh? All right. 7th graders. Did you dress up? Hey, Tupac. Okay. All right. Okay. Thank you. Yeah. Thank you. All right. Oh. Okay. 59. What are some perfect squares that radical 59 falls between? What's one that's smaller? What's less than 59? 49, radical 49, and bigger than 64, no, 67 is not a square root. All right, so between 7 and 8. Is that 59 closer to 64, or is it closer to 49? It's closer to 64. So would you say that this would be like 7 point, bigger than 0.5, maybe 7.6?
Bella Lee, please go to computer lab, David Hesse, Bella Lee.
Let's see, 59, radical 59, 7.6, look at that. I didn't know, but I said, hey, it's got to be a little bit closer to 64. It's close to me. All right. So, negative radical 41. Again, I just want to think here, negative radical 41. Radical 41, I need some perfect squares on either side. What's less than 41? 36. Okay, so negative radical 36 is less than that. And, oh, these go the different way. 49 is another one. That is true. That is reversed. Oh my God, that's difficult. Sorry. Negative radical 49, negative radical 41, and negative radical 36. I had to rewrite that because negative 7 is smaller than negative 6. And that is a mathematical error if I wrote it the other way. Negatives, smaller things always have to go to the left, and negative 7 is smaller, so we want it on the left-hand side. That's tricky. All right, so it turns out that negative radical 41 would be between negative 7 and negative 6. Okay, radical 84. Radical 84 is between, it's bigger than radical 81 and less than radical 100, so it's got to be between 9 and 10. Now, would you say, is it closer to the 9 or is it closer to the 10?
To the 9.
It's definitely closer to the 9. So if you had to approximate it, you'd 9.1, 9.2. I'd go with 9.2 myself. Let's see if I'm right.
I'd go 9.1.
Radical 84. Oh, 9.1. Yeah, 9.1, 9.2. That's okay. We're very close. All right. So I think you get that pretty well. Let's look at perfect cubes. The cube of an integer is called a perfect cube. These are easier and you don't have too many of them. So we want to know our list of perfect cubes here. 1 cubed is 1. 2 cubed is 8. Will you take a second and fill out the rest of these? You can use your calculator. Go ahead and use your calculator if you need to. Okay, beautiful. 512, 729, and 1,000 finish off that list. And again, all of these numbers are called perfect cubes. And again, the reason why it's called a cube is because you can actually arrange 64 little unit cubes into a perfect cube of 4 blocks on a side. Okay, it forms a physical cube, and that's why we call them cubes. All right. It turns out that perfect cubes can be positive or negative. All integers, positive and negative numbers, have one cube root. We can take the cube root of a positive number and we can take the cube root of a negative number. And we're going to just do this on our calculators. And the reason, well, because 2 cubed equals 8, but also negative 2 cubed, negative 2 times negative 2 times negative 2 would give us negative 8. So each of these values we can take a cube root on. So I'm going to show you on your calculator we can do cube roots. So here we go. We're going to use our calculators to learn these cube roots. Under the math menu, you right off the bat, there you see on number 4 is a cube root. It has the little 3 and the little elbow of the radical sign. So you're going to choose that cube root of 64, and what do we get? 4. And again, that was right here when we're using roots. We're just interested in whatever that base number is. What's the cube root of 343? 7, right there. What's the cube root of negative 27? Well, 3 would give you positive 27. But negative 3 times negative 3 times negative 3, that gets us back to that 27. And again, you can use your calculator. So math number 4, negative 27, and you'll see we get negative 3 for the answer. All right. What about this one, number 23? I don't know that. The cube.
Negative.
Yeah, the cube root of negative 2,197. That's crazy. That's definitely a calculator problem. Negative 13. Okay. All right, ladies and gentlemen, that's all I have for you today. Do you have any questions right now? Read carefully on the Delta Math. You do have 2 options today.